Hello guys, welcome back to our lectures. So we're gonna continue our discussion about chapter 2, the instruction set of MIPS. So but we're gonna deviate a little bit, to know what the assembler do and what the compiler do and later linker and the relation between all these components, before the execution of a file of assembly file or for example C++ file or something like this. So here is the big picture. So you have a program, this program written in C or high level language basically, or in assembly. If it wasn't written in assembly, then it will be fed to an assembler, and this assembler will convert this into binary code because the computer doesn't understand the English. So we must, convert the instruction into binary. Okay. If it was, however, written in, in C++ or C like this, then we should feed this into the compiler first. Okay. And the compiler, should convert this high-level language into assembly and provide this code as assembly to the assembler, and the assembler again will convert this code into ones and zeros. Okay. Or some compilers do a direct conversion from high level language like C into zeros and ones directly, although the compilation process will be slower. So you have some compilers that do this, and you have some other compilers that do the assembly first. Okay. And all of this is fed to the linker, and the linker will do something that we're gonna see at the end of this presentation, and then this will produce the final object file, and the object file is basically the the executable file that can be executed in the computer, or the file that the computer that can execute. So in the first step, we write our program like, for example, in C like this. Then the compiler will convert this code into assembly code like this one here. Okay. And then the assembler will take this assembly and convert it into zeros and ones. Okay. And provide this to the linker, and we're gonna know later or understand later what the linker will do with such zeros and ones. Okay. Because it's still in some cases, this zeros and ones is not understandable by the computer, and the linker should intervene to do some changes so that the computer can understand this code and execute it. And here is the big picture in which the linker come into play. Okay, the problem is that you might have multiple source files. Also, maybe you include some library, for example, like for example printf. So printf is a library, in C. So and you might also write your code into multiple files, like for example you have a function and this function is defined in some other file. So basically your program might be in multiple files, like source file 1, source file 2, source file 3. You might also have some libraries included, like hash include, like con.h or iostream.h in C++, something like this. So you must process each separate file individually. So the assembler will convert, let's assume all of them are assembly. So the assembler will convert each one into zeros and ones. So you're gonna assemble the first file, the second file, the third file. Of course, you can do this in parallel. That's one option in many compilers. Okay, and we'll convert this each source file into an object file. An object file should be executable, but also you might have like you might have included some library like printf, and still this inclusion is not resolved, because printf at the end is also a source file that you should include. Also, you didn't write this source file, so it's called the library. And here comes the linker. And also another useful job for the linker is that it resolve some of the some of the calling. So for example, let's assume this is the main file, and this main file calls a function called like add x and y, like a function that add two variables together. And add x y is written here or defined here in source file. So basically the linker will link these two together. Basically will remove the call and replace this call by the actual definition of this function. Okay, and combine all these files together, all these object files plus the libraries that you include like printf, into one executable file, one object file. But this now fully resolve it, and the computer can execute it easily. So here is the linker in more details. So here you might have an object file, so multiple object files and the library like this, like printf, okay? And in the main here, you might have some calls to some either subroutines or procedures or functions, okay? Or some library like printf. And this function, like here for example it's called subtraction, for example, is defined in another object file, and here you included or you called some C library like printf, which is again something that you didn't write yourself, and it should be included as a library. Okay, so the linker will combine all these object files and definitions and gather them all into one file. Okay, so basically now when you make the jump here to printf, you're gonna go here. When you make the jump here to sub, you're gonna go here, so exactly where to go. Okay, and that's basically the executable file that the computer can execute. That's it guys for this video. Thank you very much for watching, and see you in the next video. Bye bye.